All right, for our final stop, we're going to visit the back of our board here. We're going to take a look at the guts of it, mainly so that I can show you this connector right here. We've got a red, white, a green, and a black wire coming into our lovely Molex here. Now, some of our other units may use something a little more like this, where we've got a 3M connector that it plugs into. Either way, this is going to be our CANBus cabling. So we've got our red, which is going to be our 12-volt positive. That should always read and display whatever your house voltage is at. So your battery voltage, or if you've got your converter plugged in, it'll show your converter voltage. Your black is ground, so everything we test is going to be against that. And then our white and green are going to be the CAN networks, the CAN cables. So those always are going to communicate at 2.5 volts each, or in the neighborhood of. Together, they have to add up to 5. That is a regulated thing. And what it does, basically, it pulses voltage and uses that to communicate ones and zeros that are used for code, and that's how things communicate to each other over the CAN network. The last thing we want to make sure we take a look at, anytime we're experiencing just some wonky behavior that doesn't make a whole lot of sense in a multiplex network, what you want to do is you want to check resistance on your network, on your cables here. So for resistance, a couple important things. One, we don't really care about the black and red wire in this instance. It doesn't show us anything important for what we're looking for. We are only concerned with the readings on our green and white here, our network cables. Second important thing, power absolutely must be off. If power is on, any sort of power touching this network, we're going to get our reading down here on our meter bouncing around like crazy. You won't be able to get a good read. So what we want to do, we want to place one of our meter leads in the white, one of them in the green. It's easier to back probe sometimes. And what we should see, like we see on my meter now, is in the ballpark of 60 ohms. If you're looking at 120 ohms, you are missing a terminator somewhere in the network. You're missing a resistor in the network. If you're seeing 40 ohms, you have one too many resistors in the network. So seeing 60 right there, we are perfect. We get the right amount of resistance for what we need to do, and our system should be working correctly.